All right, these are molarity practice problems number 2. Okay, we're going to change things up a little bit because what happens if I don't know moles? Okay, and instead we want to know grams. Okay, there is a calculation. We've learned how to convert moles to grams, right? But we're going to put this all together on this one. Okay, so we can solve for grams. Instead of solving for moles and then converting for grams, we can do this by taking my molarity times my liters times my molar mass. Let's recall molar mass we learned how to do in the 4-6 weeks when we were doing stoichiometry. Okay, so if I'm solving for grams, it says take your molarity times your liters times your molar mass. All right, so let's look at number 1. How many grams of potassium carbonate are needed to make 200 mils of a 0.25 molar solution? Okay, so first things we want to do is we want to convert milliliters to liters by moving the decimal 3 places again. So I'm going to go 1, 2, 3. So that gives me 0.2 liters of solution. Second, I want to find molar mass of this potassium carbonate. Okay, let's recall how to do that. Molar mass. I've got potassium. How many potassium atoms do I have? 2. Then I've got carbon. That's not cobalt. Cobalt would be big C, little o. This is big C, big O. So that's 1 carbon and 3 oxygen. Okay, now use your periodic table to find the atomic weights. Okay, potassium, 39. So 2 times 39. All right, which is what, 78. Then I have 1 carbon, which is 12. And I have oxygen, which is 16, is 48. And then I'm going to add this all together. Okay, so there's 8 plus 8 is 16, 17, 18, 7, 8, 9, plus 4 is 138. So I've got a molar mass of 138 grams. So now I have everything I need to solve. I've got molarity, I've got liters, I've got molar mass. So grams equal molarity, 2.5 molar solution times my liters, 0.2 liters, times my molar mass. Okay, now I'm just going to multiply all of those together. All right, so here we go. 2.5 times 0.2 times 138, and we get 69. So we have 69 grams of potassium carbonate are needed to make a 200 ml solution of a 2.5 molar solution. Oops, 200 mils of a 2.5 molar solution is what I'm trying to say. Okay, so there's our answer. Now, what if I want to solve for molarity? It's the same as last time. What is the concentration, which we know is molarity, of a 450 ml solution that contains 200 grams of iron 2 chloride? And I remind you here, don't forget to convert milliliters to liters. So you'll want to do that first, but let's look at that. If I'm solving for molarity, what are we going to do? Right, we've got grams on top. So when I'm doing this, I'm going to put molarity equals grams on the top, liters times my molar mass on the bottom. Okay, now I'm ready to plug in my numbers, right? So how many grams do I have? 200. Times my liters, 1, 2, 3, so 0.45 times my molar mass. So again, you need to solve for molar mass. I've got 1 iron, and I've got 2 chlorine. 56, 35, 70, and 56. So So 126. So 126. Then I will solve. Okay, so you're just plugging those numbers into the calculator. So again, delete. We're going to hit Control Divide. Ooh, what is happening? Clear, clear, clear. Control Divide. There we go. On top, I've got 200. On the bottom, I got 0.45 times 126. Remember, if you hit Control Enter, it won't come out as a decimal. Then we can round that off to 3.53. What? What were we solving for? Molarity. Big M. All right, what if I'm solving for liters? Go here. How many liters of a 0.88 molar solution can be made with 25.5 grams of lithium fluoride? So again, I cover that up. It says grams divided by molarity times molar mass will give me liters. All right, so you should be able to do 3, 4, 5, and 6 of this worksheet. Let me know if you have any questions.